On to our next topic. We're going to go over proportional versus non-proportional relationships. So first off, let's talk about their equations. On a proportional equation, we have y is equal to m times x. Our y is our output, on both of these. Our y is what we get after we follow the rule of the equation. Our m on both of these is our slope. Our m is our slope. That's how much things change from one line to the next. The slope is how much my graph goes up or goes down. The x is the input, what I'm starting with. My starting number that I'm plugging into the rule. And then what makes a non-proportional graph or equation, different than a proportional equation is that it has a b. The b is the y-intercept. The y-intercept is where on your graph, where your line crosses that y-axis. This point right there, that would be my b, where my graphed line crosses the y-axis. Non-proportional relationships have a b. Non-proportional relationships don't have a b in their graph because they go through the origin. The proportional graph goes through, there's no either, the origin. Remember, origin's spelled funny, O-R-I-G-I-N. There we go. And this one, the y-intercept, which is the b, is not at the origin. And then lastly, the tables. On a proportional graph, you're going to be multiplying times something every time. We're going to be multiplying times the same number or dividing by the same number every time. So for here, how do I go from 3 to 12? Times 4. And that's going to be the same for all of these. 1 times 4 is 4. 0 times 4 is 0. So you're going to be multiplying or dividing by the same number each time. This one, we go from 6 to 3. Multiplying or dividing, how do I go from 6 to 3? I divide by 2, or I can multiply times 1/2. How do I go from 10 to 5? Again, divide by 2, or I can multiply times 1/2. It's the same way for every set of rules, every set of numbers. Divide by 1/2 or multiply times 1/2. Multiply or divide by the same number each time. Another way that you can see it, if you do y divided by x, you get the same number each time. So for example, if I look at this one, the second table, y divided by x, 3 divided by 6 gives me 1/2 because I can divide both those by 3. 5 over 10, that simplifies to 1/2. 6 over 12, that simplifies to 1/2. I get the same number. Well, y'all can't see. I get the same number every time I simplify. Those things are not true over here. Like we talked about in the school year, this is the non-proportional equation for 7th grade. When you get into 8th grade and upper levels of math, you'll see this equation up top. So when I'm talking about the table, I'm only referencing this equation, y equals x plus b. So if I come down here, we're going to be adding or subtracting by the same number each time. So 4 to 9, what number do I add or subtract? I add 5. 6 to 11, add 5. 10 to 15, I add 5. I can also subtract by the same number every time. How do I go from 4 to 2? I subtract 2. 5 to 3, subtract 2. 6 to 4, subtract 2. And the last thing for non-proportional tables, if I do y divided by x, I'm going to get a different number each time. So for example, if I look here, if I do 2 divided by 4, y over x, so 2 over 4, that simplifies to 1/2. If I do 3 over 5, that doesn't simplify to anything. If I do 4 over 6, this simplifies to 2/3. 1/2, 3/5, 2/3, those are different numbers each time. That's another way I can tell that my table is non-proportional. If you have questions about that or need a little bit more of an explanation, please let us know. Otherwise, go ahead and go on to the activity.